Okay, hello everyone. Let us continue the third part of today's course. Okay, so from figure 1 we know that first t1 of 1 is equal to 0. Okay, why? Okay, because we can see that T1 of 1 denotes the time index of the first transmission on channel 1. Okay, so on channel 1, the first transmission, the time index T is equal to 0. Okay, so T1 of 1 is equal to 0. And then T1 of 2 is equal to 4. Okay, T1 of 2 is equal to 4. Why? Okay, because T1 of 2 is the time index of the first transmission, second transmission on channel 1. Okay, so we can see that the second transmission, this is the first transmission, this is the second transmission. Okay, so the second transmission on channel 1, the time index is equal to 4. Okay, so and they let us try to find T2 of 1. Okay, it is equal to 2. Okay, why? Because T2 of 1 denotes the time index of the first transmission on channel 1. So the first transmission on channel 1 is this. Okay, and the time index is equal to 2. And next, let us find T2 of 2 is equal to 4. Okay, why? Because T2 of 2 denotes the time index of the second transmission on channel 2. Okay, so this is the second transmission on channel 2. So the time index is 4. And finally, we want to find T2 of 3. Okay, which is equal to 6. Okay, why? Because T2 of 3 denotes the time index of the third transmission on channel 2. Okay, so the third transmission on channel 2 is this transmission, and the time index is equal to 6. Okay, so let us call this equation 1. Okay. Okay, then let us consider the capital Ti. Capital Ti. Okay. Okay, capital Ti denotes the total number of transmission on channel I by time t. Okay, so from figure 1 again, we know that first we want to find T1 of 0 is equal to 1. Okay, why? Okay, because T1 of 0 denotes the total number of transmission on channel 1 by time 0. Okay, total transmission, number of transmission on channel 1 by time 0. Okay, so there is one transmission. And then we want to find T1 of 1 is equal to what? Okay, we can see that T1 of 1 denotes the total number of transmission on channel 1 by time 1. So by this time, okay, the total transmission is 1 and 0. Okay, so totally is equal to 1. Okay, similarly, T1 of 2 and T1 of 3 are also equal to 1. Okay, T1 of 2 and T1 of 3 is also equal to 1. Okay, and next we want to find T1 of 4. Okay, T1 of 4, let us see. T1 of 4, okay, channel 1 and at time by the time 4, okay, we totally have two transmissions. So this is equal to 2. And for the T1 5 and the T1 6, there are also two transmissions. Okay, so this is equal to T1 5 and is equal to T1 6. Okay. Okay, so we call this equation 2. Oh, sorry. Okay, let me merge these two lines. Huh? Oh, okay. So how can I merge these two lines? Also, okay. Two lines is also okay. Okay, so next we want to find T2 of 0. Okay, it is equal to what? Okay, T2 of 0. Okay, on channel 2, on time 0, there is no transmission. And when time index is equal to 1, there is also no transmission. So T2 of 0 is equal to T2 of 1, which is equal to 0. Okay. Okay, then we want to find T2 of 2. Okay, so T2 of 2 is on channel 2 and by time 2. Okay, there are totally one transmission. And by time 3, there is also one transmission. So T22 is equal to is equal to 1 and is equal to T23. Okay. So next we want to find T2 of 4. Okay. And T2 of 4, okay, channel 2 time 4, Up to time by time 4, there are 2 transmissions. So this is equal to 2. And please note that when for T25, okay, for T25 channel 2 time index 5, there are also 2 transmissions. So they are equal. And finally, for the T26, okay, T26 for channel 2 by time 6, there are totally 3 transmissions. So this is equal to 3. And we call this equation 3. Okay. Okay, then according to equation 1.2, the total reward by time t is okay, is this equation. Let me see. R of t is equal to the summation. Okay. I is equal to 1 to k, and summation n is equal to 1 to ti of t. So I need to adjust this summation. Okay. Okay, so this is the summation. Okay, this is I is equal to 1, and this is capital K, and this is another summation. So this is equal to n is equal to 1, and this is ti of t. Okay, and here is the si of ti of n. Okay. Okay, I call this equation 4. Okay, like this. Okay, in this example, there are k is equal to 2 channels. Okay, therefore, okay, we first find the R0. R0 is equal to the summation. Okay, we can copy this and paste here. Okay, I is equal to 1 to k. Oh, sorry, I need to adjust. It should be italic. Okay, and it is should be italic, and it should be italic too. Okay, so I is equal to 1 to k. Okay, so now k is equal to 2, which is the number of the channels. Okay, so t is equal to 0. Okay, so t is equal to 0. Okay, good. So it is equal to 2 summation. Okay, because the first summation is summation I is equal to 1 to 2. So we can expand the summation. Okay, so first summation is this. Okay, n is 1 to t1. Okay, I is equal to 1 of 0. And s1 of t1 of n. Okay, then plus. Okay, here t2. No. N is equal to 1. And now I is equal to 2. So I change this 1 to 2. Okay. So this 1 should be changed to 2. And 1 to 2. Okay. So next. Okay, so what is the value of t1 of 0? Okay, let us see. t1 of 0 is equal to 1. Okay, so summation n is equal to 1 to 1. Okay, there is only one n. So this is equal to s1 of t1 of 1. Okay, like this. And plus, okay, we copy this and paste here. t2 of 0. Okay, t2 of 0 is equal to 0. Okay, like this. Okay, but the summation n is from 1 to 0. There is no term to sum up. So there is no term in this summation. So this summation is equal to 0. Okay, like this. Okay. Okay, so finally, alas. So it is equal to s1 of t1 of t. Okay, s1 of t1 of 1. So what is t1 of 1? Okay, according to equation 1, it is equal to 0. So we can replace this term by 0. Okay, s1 of 0. Okay, and what is the value of s1 of 0? Okay, we can check the table. s1 of 0, okay, is this term. So this is equal to 1. Okay, so we have found that oh, wait a minute. So I need to move it out and align. Oh, I cannot align at the equality. So that is okay. So I call this equation equation 5. Okay, like this. And I move this equation to the center. Okay. Center. And this is cancelled to 0. Okay, like this. Okay, so we have found that r of 0 is equal to 1. Okay, similarly, we can find r of t therefore t is equal to 1, 2, to 6. Okay. Which is easy to find. Therefore, I leave it to you as an exercise. Okay. So this is this concludes our solution. Okay, any questions? Okay, if you do not have any questions, let us continue to our slides. Okay. So we have shown you example to explain these 2 points and the equation 1.2. Okay, now let phi of t is in this set 1, 2, to k be a selection rule that indicates which channel is chosen for transmission at time t. Okay, for example, if phi of 1 is equal to 1, then at time 1 we need to choose channel 1 for transmission. Okay, which is a mapping from the observed history of the process. That is, all past transmission actions and reward observations up to time t minus 1. Okay, to 1, 2, to k. Okay, a policy phi is the time series vector of selection rules phi. Phi is equal to phi of t, and t is equal to 1, 2, etc. That is all the natural numbers. Okay, we have finished teaching the network model. Do you have any problems? Okay, if no questions, let us continue to performance measures of the online learning algorithms. Okay, by viewing the cognitive user as a player or agent and the channels as arms, okay, we will explain what is an arm, okay, later. The player can choose so as to maximize the long-term accumulated reward. The network model described can be cast as a restless multi-armed bandit, which is abbreviated as RMAB problem, which is a generalization of the classic multi-armed bandit MAB problem. Okay, let us see what is the multi-armed bandit MAB problem first. Okay, please look at the handout and search for the MAB. Okay. Okay, page 20. What is the basic multi-armed bandit MAB problem? Answer. In probability theory and machine learning, the multi-armed bandit problem, sometimes called the capital K or capital N armed bandit problem, is a problem in which a fixed limited set of resources must be allocated between competing alternative choices in a way that maximizes their expected gain. Okay, for example, for the K-armed bandit problem, it is similar to we have a set 1 to K channels. Okay, when one channel is a resource, and these channels must be allocated between competing users. Okay, that is the primary users. Okay, it is 25 minutes. Okay, see you next time. Goodbye.